friends, greetings. On the occasion of 66th National Day for the entire Malaysia, I want to congratulate and wish a very bright future for the country. On the special day, I thought, why not do some kind of analysis with the help of machine learning and artificial intelligence to bring out some important information from the Independence Day speeches that were given by the beloved prime ministers of the country. And I have taken the Independence Day speeches from the year 2013 till date. I have used natural language processing techniques to analyze the speeches that are delivered by the prime ministers of this country. Right from the year 2013 till this year, we had different prime ministers from Mohammed Najib bin Abdul Razak till Anwar bin Ibrahim. All these different prime ministers have delivered their speeches. When we analyze these speeches, we will get to know what is the message that our leaders are conveying to the citizens of the country. Let me walk you through with my work. So we are trying to do topic modeling on the Independence Day speeches. The context basically is to understand the insights from the speech themes. When you analyze these Independence Day speeches, we can try and understand what is that core message that our leaders are conveying to the nation. Now, I want to understand what is topic modeling to start. Topic modeling is an NLP technique which, of course, uses statistical concepts in order to discover the topics which are hidden in the entire speech. It allows us to understand the large text data. It tries to interpret this entire text data by splitting it into topics. It also allows us to summarize the data, understand the themes, right? We also be able to group the documents from this vast corpus that we are able to analyze. And thanks to these concepts, we'll be able to understand the patterns, the sentiments that are displayed in the textual data. Now, in order to do topic modeling or any textual analysis, the first and foremost thing is we need to do data pre-processing. This data pre-processing basically talks about cleaning the text data, like removing these special symbols, numbers, punctuation marks, unwanted text data, and then we will have to tokenize this particular text data. Tokenization basically means you're splitting the data into words, which is basically the independent unit which gives us the meaning. So we'll have to try and take the entire text data, remove the unwanted things, and then break it up into words. Once the words are created, we will of course also have to do something called as stemming or lemmatization, which allows us to try to take the text in a single form. Because when we talk about textual data, the language, it can be having different forms of the word. So we try to convert that into a single form. That's called as lemmatization. And once we remove the unwanted words, then you'll have clean corpus, clean data. Now, once this clean data is given, we will apply topic modeling. There are many different techniques that we can apply. LDA is one of the popular techniques to apply the topic modeling method on the speech data. LDA stands for Latent Dirichlet Allocation. And if you already are familiar with the textual data analysis, then you're familiar with the topics like corpus, document, then tokens. Tokens are also words. Now, LDA is trying to do a reverse engineering on this. From the corpus, we get documents. From the document, we get words. But here in LDA, we try to drag the information out, infer the information out by trying to bring up something called as topics. We bring up topics. The document to topic relationship is something that we define. Likewise, topic to word relationship also has to be. And when we talk about LDA or when we talk about data analysis, you need to remember that any data that we are trying to analyze by default goes into the normal distribution method. But in LDA, we don't talk about normal distribution things. We will talk about something called as Dirichlet distribution. This is the mathematical concept for your LDA implementation. Now, the steps that we basically implement for deriving the insights is we try to define the number of topics. We decide on that, right? Choose a set of topics. Then we try to assign topics to words. So we are trying to distinguish and segregate the tokens that we obtain from the corpus into these topics. We will quantify the percentage also on each word assigned to a specific topic. What is the percentage of contribution that token is putting into the topic? And thereby we will get the results. The entire documents are generated with words assigned into different topics. So more like a clustering concept if you are thinking. Then we try to represent the result in a nice visualization aspect. You can see here we will have 3 topics, and these 3 topics are represented in a scatter diagram to start with. This also shows the difference between the topics. If the circles that you see on the left side in the scatter diagram are close enough, that means the topics are having similar information. Farther these topics, more distinguished information that they get. And on the right side, you see the bar chart which represents the respective topics, results with respect to the contribution of the tokens in those topics. The blue color represents the overall contribution. The red color represents the contribution of that particular token in a specific topic. Let us now try and do the hands-on. I'm going to use Jupyter notebooks for representing the entire work. So this is my Jupyter notebook, which is basically performing the topic modeling on the speeches that we have captured from the year 2013 to date. One of the interesting libraries that we are using here is PyLDA VIS, Python LDA visualization library, which is giving us the visualization capacity for the results that we are obtaining on the LDA model. Gensim is the library in Python which allows us to perform LDA, and in an extension we also have Python LDA visualization. I'll import this, I will load the data, and you can see there are these speeches captured from year 2013 to 2023 by various prime ministers of the country, right? And these are the respective party that they represent from, and this is the tenure of their service, and these are the speeches, right? There are 10 different year speeches that we see. Then we are trying to clean the data. To start with, we are defining the limmatization. I'm defining a custom function. I'm also defining another custom function here to pre-process the entire data. So let us load the data, and this is basically the pre-processing code, and we are running that pre-processing code on the data here that we've loaded. For demonstration purpose, I'm taking the year 2015, and you can see it cleans the data and gives us the processed speech by splitting the entire speech into documents, and then also you can see the tokens, comma separated words. So this is basically how we pre-process, and here we are talking about the custom function which is training the LDA model. So we'll run this. This is the custom function which is trying to capture the topic, the percentage, the keywords, and the text snippets from those keywords, and we will use the Gensim library here to process the data, and this is basically the output. The length of the total length of the dictionary is 564, and you can see some of the words as the snippet. Now, out of all these words, you need to understand that you will be interested in specific words which give you contextual meaning. While the dignitaries are delivering these features, they probably have a specific style, and they probably will be using certain keywords regularly. So we have to try and capture contextually meaningful words. In order to do that, I'm writing a logic here which basically says to capture 100,000 words, but these words not just having the maximum occurrence, but we are also looking at minimum occurrence. So I want the words which are represented at least 5 times, and I'm also talking about these words being present in 50% of the documents, not more than that. That way I'm trying to ensure that the regular, the more frequently used keywords or the words are eliminated, and we are only focusing on specific keywords. Once we have defined this, we will try and create the bag of words, and we will print the corpus. You can see the length. We have 53 keywords. Now, using these keywords, I'm trying to split the entire data into 3 topics. We are defining the number of topics as 3. You will decide if it will be 5 or 10. That's something that you would be experimenting. And I'm using the LDA model, which is imported from Gensim library, passing all the parameters, and then here we are iterating on each document. So topic wise, we will be able to capture the words with the percentage of the content. Now, once we obtain this, we will try to capture all this information to analyze the document. So we are using the trained model on the corpus and clean data to capture the documents, which are basically segregated into 3 topics. We are creating a table to specifically capture all the information in an organized fashion, and we are creating a data. And once the data frame is ready, you can see this is the information that we get. The ID is the document ID, and we have main topics. Remember, we have split the entire document into a set of documents into 3 topics. So you'll have 0, 1, 2, the topic IDs. And what is the contribution of this particular document in this topic? So thereby, we will be able to look at all the 53 documents contribution to these 3 topics. These are the keywords from the respective documents, and then we also have the snippet of what are the keywords that we have in those documents. Now, using the visualization library PyLDA-Viz, we are trying to represent the captured details into scatter diagram and bar chart. You can also skip to the next topic to analyze each topic in detail. What are the key tokens and how many tokens are contributing heavily to this topic, and what is the percentage of that particular keyword in the overall document as well as in that specific topic. So this way we can analyze the entire text document in order to capture the related. We are trying to capture the entire information here in order to get the meaningful insights from all the speeches. Now, using the code, you will be able to also compare year on year the trends of our leaders. What is the vision that we have and in which direction we are actually moving as a nation? All these analysis can be done using this topic modeling on Independence Day speeches. Once again, congratulations on the 66th National Day, and thank you so much for watching.